Hi everybody, and welcome to the video on loops. Loops are probably the most foundational concept we'll talk about this semester. They're also probably the most powerful tool we will use this semester. So this video is sort of the most important of the course so far. Based solely on this video, you can't see how powerful loops are. We will see how powerful they are as we write more and more sophisticated programs. And especially in your group project, you will come to see how powerful they are. But for now, this is just an introduction, and just take my word for it that we'll see how useful these are as the semester progresses. So let me just motivate what a loop is and why you would need one. So let me just bring up, this is the program from last time, and it's this one where, I ask a college classmate if she wants to go out with me, and then based on what she says, I tell her various things. So if she says yes or yes, then I express my deep and abiding love. If she says no or stop asking me, then I have a follow-up question for her, and I'll put various things based on what she says. What I want to focus on, though, is this code down here at the end. So if she says yes, then do this. Otherwise, if she says no, do this. Otherwise, if she says something I wasn't expecting, then I print it to the screen, invalid input, please try again. Notice, though, that there is no way for her to try again. So even if I get her response again, right, cin whatever her response was, input, even if I add that line of code right there so she can try again, the program still ends. Right? So right here after that, there's just this return 0. So I suppose what I could now do is copy and paste all of this and put it right there. Okay, so the logic of this is she says yes or no or stop asking me. If she says something invalid, then I get her input again, right? So sorry, let me get rid of that. I get her input again, and then the program runs like this again, right? But what if she again enters something invalid? If she enters something invalid again, then I guess I would have to put that code in there again, right? So at the very beginning, I ask her, do you want to go out with me? I get her response. If she answers what I expect, then I output my stuff. If she enters something invalid, I ask her to try again, and then the same thing happens again here. Right. Otherwise, if invalid input, please try again. So I get it again, and then run the same code, etc. Right? But what if she just keeps telling me invalid things? Right? I don't want to have to keep copying and pasting all this code. Right? That's really inefficient, and it's really a time waste. So let me just put the original program back in. Here it is. So what I really want is a line of code basically right here. Okay, so when I get her input, what I want is a line of code that says, if she entered something invalid, then tell her it's invalid, let her redo her response, and keep doing that until she enters something valid. Okay, so that's the idea of a loop. So keep having her do this until she does it properly. Right? So that block of code can run 1,000,000 times if she keeps entering something invalid 1,000,000 times. Okay, so that's sort of the idea of why you would need a loop. So a loop basically just means you run a line of code and then you run it again if need be, right? If some condition is true. So right here in my code, I'd like some line of code that basically says, as long as she's entering something invalid, please tell her to give her input again. Okay, so another example of why you might need a loop. So imagine that you're playing a hangman program where the output on the screen is the asterisks, right? So the word is covered up, and the hidden word is therefore. So suppose that the user enters the letter E. What the program should do is go through this word here, this covered up word, find all of the E's, and flip one over every time you find it. And most importantly, you should do this until you reach the end of the word. Right? So as long as you have not reached the end of the word, you should keep doing this. Keep trying to find the E's and turning them over. Okay, so the upshot of all this is, if you ever find yourself describing what you want the program to do in English, and you use the phrase as long as, or you use the word until, that's when you use a loop. A loop lets you do something until a condition is not met anymore, or as long as a certain condition is true. The same code will run over and over and over again. So here's the syntax of it. So it's basically looks like an if statement where instead of an if you write the word while. You put a Boolean statement inside the parentheses. You put whatever code you want to occur inside and then close it with a brace. And just like with an if statement, there is no semicolon here at the end. So basically what will happen here is if this statement is true, this code will run. Once this code is done and you get down to the end of the loop, the computer will ask, is this statement still true? If it is, this code will run again. And you get down to the end, the computer will ask, is this statement still true? If it is, this code will run again. Over and over and over again, until this statement inside the parentheses becomes false. If this statement inside the parentheses is false from the get-go, then just like with an if statement, the computer will skip right over this while statement here. Yeah, so in English, while maybe isn't the best word. Basically, when you're reading somebody else's code and you see while, you should read it as long as. So as long as this statement is true, keep running this code. As long as the statement is true, run this code. So here's a first example of a loop. You set x equal to -1, and I'm missing my semicolon there. Right? That's bad syntax. But anyway, so consider this while loop here. While x is less than or equal to 0, tell the user, please enter a positive number, and you'll get it from them. Okay, so these two lines of code are inside the loop, and since x is less than or equal to 0 right here, you're going to enter the loop. The computer won't skip over it. What happens is now the user enters a number, and that number is saved as x. If that number is still less than or equal to 0, this loop will run again. Okay, so as long as the value of x is less than or equal to 0, this loop will run. So let's just see how this works in an actual program. So let me just copy and paste all of that into here. Oops. Sorry, I don't need 2 return zeros. Okay, so let's run this. Oops, sorry, this should be a -1, right? So notice though, since x equals 1, x is not less than or equal to 0. So the computer just skipped right over this loop, right? Just like it would an if statement. So let me make it a -1, so we'll enter the loop. And now let me run it again. So it tells me, enter a positive number. Suppose I enter a -4. Then right here in the code, x has the value of -4. Okay, so the computer gets down to this brace, and it checks whether or not x is still less than or equal to 0. And in this case, it is, right? -4 is still less than or equal to 0. So it will ask me again, right? Ask me again. The computer can do this all day, right? The computer is not annoyed that I keep doing this, that I keep flouting its instructions, right? So finally, if I enter a positive number, like say 6, well, 6 is not less than or equal to 0. So right here in the code, x now has the value of 6. So the computer, when it gets down to this brace, checks whether or not the statement is still true, but it isn't true anymore. So now we break out of the loop, and it tells me your positive number is 6. Okay, so again, in plain English, this is saying as long as x is 0 or smaller, keep doing these 2 lines of code. But as soon as x is not less than or equal to 0, then break out of that loop and continue down in the program. Okay, so that's how the loop works. So let me show you some more examples here and some applications. Okay, so yeah, the response is 1. As long as the response is equal to 1, the computer will tell the user hi. And so now the computer asks, do you want me to greet you again? Enter 1 for yes, and any other number for no. So basically what this loop allows the user to do is, it allows the user to keep having the computer greet the user if the user wants. So let me put this code in my compiler. Okay, oops. And run it. So what happens at the very beginning is that response is 1. right? I initialize response to 1. Therefore, this statement is true the first time the computer encounters it. So inside the loop we go. So the computer outputs hi, outputs a new line, and then asks me, do you want me to greet you again? Enter 1 for yes and any other number for no. And then it gets my response, right? CN response. So if I enter a 1, then now 1 is inside of response. And when the computer gets down to this closing brace for the while loop, it will just ask, is response still equal to 1? And if so, it will do the loop again. So notice, right? Would you like me to greet you again? Enter 1 for yes, any other number for no. So if I enter 1 again, it says hi, right? Hi, hi, hi. But if I enter some other number like 8, what will happen is now 8 will be saved as the value of response, and 8 is not equal to 1. So this statement then becomes false, and the computer breaks out of that loop and continues with the program, and now the program ends, right? It did not ask me again. So you can just keep doing something to the user as long as they want, for example. But yeah, so it tells me here my next example for you is the dating program. So let me show you how we can tweak that dating program to do what I just said. Oops. Okay, so here's the dating program. So what I want is, when this runs, do you want to go out with me? If she enters something invalid like this, what I want is for it to output this, say please try again, and let the user try again. And then if they still enter something invalid, try again, and try again, until they do something valid. So what I'm going to do is, I'm going to write a while here, and then I'm going to put it up here. And I need braces around this because what I want this to do now is get their response again. Okay, so what's going to happen? I'm going to ask, do you want to go out with me? And I'm going to get the response. As long as that response is invalid, right? This statement here, if you remember from last time, represents all the invalid inputs. As long as the user enters something invalid, it's going to say, invalid input, please try again, and then get a new response. That's going to get the input again. And it will keep doing this until the user plays along. So do you want to go out with me? Hi, that was invalid. Please try again. No is valid, so, whatever, right? If they enter anything that's not valid, that's not what the computer is expecting, it will just keep prompting. Right, so maybe I'll go out with you. Oh, that was invalid. Right? I don't like that. But as soon as I say something that the computer is expecting, like the word yes, then look, it broke out of the loop. At this spot in the code, input is now yes. So when the computer gets to this brace, it asks itself, is that input still invalid? And the answer was no. Now the input is valid. So since the input is valid, I break out of this invalid statement here, and I move on with the code. So here's one important use of loops. If you want the user to enter something in a certain way, you can set up a loop that will basically say that it will force the user to keep inputting something until they give you what they want. Sorry, what you want, right? So if you want the user to enter yes, or no, or stop asking me, you can set up a loop that will force them to do that eventually, right? That will keep telling them, please try again, please enter the input again. Okay, so there's one of the more important uses of a loop. Especially when, if your user mistypes, you would like for them to be able to try again, right? So if they mean to type yes, but they have a typo, and instead they write TES, right? Because T is right next to the Y. You want to give them an opportunity to enter the YES, right? Not just exit the program. Okay, so here's another use of the while loop. You want to write a program in which the user enters as many numbers as they want, and then you give them the sum of those numbers. Here's some code that would do that. So I declare my variable number. I initialize my sum variable to 0 because at the beginning nothing has been added. So then I tell them, enter a number, enter a non-number character when you are done. And so notice this while loop here. What it's saying is, as long as the user is entering a number, do this stuff in here. And so even though this statement in here doesn't look like a statement that can be true or false, it actually is a Boolean statement. So num, this number variable here, it was declared as an integer. So as long as the users are entering integers, this loop will run. But as soon as they enter something that's not an integer, now you're doing something false because you're saving the letter D or whatever as an integer, and then it will break out of the loop. So let's talk about the logic of what happens here. As long as the user is entering an integer, it will take the value of sum and assign it the previous value of sum plus the number that the user just entered. And then it will ask them for a number again. And it will just keep doing this until the user breaks out of the loop by entering a D or something. So let me see if I have this. Yeah, okay, so here's that code. So let me put that in. Okay, so let's make sure this works. So first I'm going to enter a 2. Okay, so right now, since 2 is an integer, I went into this loop because the statement was true. And what did this loop do? It took sum and took the previous value of sum, which at this point is 0, and added 2 to it. And now that's the new value of sum. So right now in the code, sum has the value of 2. So let me now enter a 3. Well, 3 is an integer, so the statement here is still true inside the while loop. Now the previous value of sum is 2, and the new number I entered was 3. So 2 plus 3 is 5, and that's now the new value of sum. So let me just do one more, and then let me break out of this by entering a non-integer like f. Okay, your sum is 9. So notice it did what we wanted. 2 plus 3 plus 4 is indeed 9. So here's another cute use of loops. You can just keep updating the value of the variable sum as you go, right? Every single time the user enters a number, you're tacking on that number they entered to the variable sum. So at the beginning, sum was 0. After the first number, sum was 2, because 0 plus 2 is 2. And then when the user entered 3, well now 2 plus 3 is 5. And now when the user enters 4, 5 plus 4 is 9. So when I broke out of the loop by entering an f, the value of sum was 9. So when I say print that value to the screen, it prints out 9. Okay, so this is a way of updating and keeping track of what the user is giving you, if you want, using a loop, right? Okay, so suppose you want to run a loop a fixed number of times. So suppose that for whatever reason I tell you, I want this loop to run exactly 10 times, and every time it runs, I want you to print to the screen high class. Here's sort of a cheap way to do that. So I have a variable that I've called counter, and it's just going to count the number of times the loop is run, essentially. So as long as the value of this variable is 10 or smaller, this code is going to run. And notice what happens. At the very beginning, 1 is less than or equal to 10, so I go into this code segment. I print high class, and then I up the value of counter by 1. Okay, remember that's what this plus plus does? So counter used to be 1. At this point in the code, it's now 2. Okay, but 2 is smaller than or equal to 10. So the loop will run again. Right? This statement is still true. I'll print high class, and now I'm going to update the value of counter again. The value was 2, now it's 3. And so on, right? So can you see how this goes? You're upping the value of counter by 1 every time the loop runs. So at some point, the value of counter will be 11, and at that point, you'll break out of this loop. So here's a cheap way of making a loop run a fixed number of times. You have a variable that's keeping track, essentially, of how many times the loop is run, and once that variable achieves a value that's too big, then you break out of the loop. Okay, so consider this code segment here. Notice it's the exact same code segment I had on the last slide, except I've removed this counter plus plus line. Okay, so the counter plus plus line is gone. So now, if you run this code, what do you think will happen? Okay, so you should think about that, but let's run through the logic of it. So the value of counter right here is 1, right? 1 is less than or equal to 10, so you enter the while loop. The code inside of the loop runs, it outputs high class, right? And now when the computer gets to the end of the loop, it asks, is the statement here still true? Well, it is still true, right? Because the value of the counter variable hasn't changed. Now, you see that? I didn't change the value of counter inside of this loop. So the computer gets back up here to the top and says, okay, the statement is still true, so I'm going to run this code again, right? And then it gets to the end of the brace, and the value of counter is still 1, so this statement is still true, so it's going to run this code again into perpetuity, right? There's nothing that's going to stop this loop from stopping. So the loop will run forever, and just to see what kind of nonsense it outputs to your screen, let me just do that exact thing. So int counter is 1, and then as long as counter is less than or equal to 10, I'm going to see out high class. Okay, so let me just hit play, and let's see what this does. Oh no, right? It's just running. It's telling me high class over and over and over again, right? It will not stop. Well, in theory, it doesn't stop ever, right? In practice, it will stop when my computer crashes, right? So notice, I mean, look at all this output, right? Scroll. It outputted like, what, 10,000 high classes or something, right? Ridiculous. And the reason is because you would never break out of this loop because you never found a way to make the statement false. So let me just actually change the value of counter sometimes. So let's run this code and see what happens. So the value of counter is 1, so I enter this loop. I output high class, but the new value of counter at the end is 1 plus 2, which is now 3. And then the next time you run the loop, counter will be updated to 5, because you do the previous value plus 2, and so on. So when I run this, it only outputs high class 5 times, right? Counter is initially 1, so I go in, and then it becomes 3, and then 5, and then 7, and then 9. So it runs for all 5 of those values. But then counter becomes 11 at some point, right? After the 5th iteration of this. And as soon as counter is 11, 11 is not smaller than 10 anymore, so you break out of the loop. Okay, so the point of this question is, or the point of this example is that infinite loops are bad. Okay, you shouldn't have them. And sometimes, if you're not used to loops, of course, there are all sorts of mistakes you can make. But here's one mistake you can make. You can accidentally create a loop that will never stop running. And so if you see output to the screen like what I just had, where it just keeps doing something over and over and over again, you probably have a loop that you didn't create a way out of. Right? So you'd have to go back into your code and check to make sure you don't have any infinite loops. Okay, and that is an introduction to loops.